not using inverse operations. I want to be clear about what I'm looking for with that. So if you need to make corrections, do so. It'll help you in preparing for the next test. With the first problem, if it's 8/5 of A is equal to 4, the idea was to use multiplication by the reciprocal to get A alone, so you'd have to multiply that by 5/8. But we have to multiply both sides. If we don't keep them equal. So this simplifies into just A, because 8 over 8 is 1, 5 over 5 is 1. 4 over 8 is the same as 1 over 2, and then we just have 5 over 2. So you could have left it as 5 halves, or changed it to 2.5, your choice. The next question was 3k is equal to -2. So if we undo the multiplication with division by that same value, -3 divided by -3 is 1, therefore 1k. Negative divided by negative is a positive. That's just 2/3. We leave it as 2/3. Done. For number 4, there were two parts, A and B. A is to write the equation. And the equation was to be written like this: AX is equal to B. So in other words, some number times X is equal to another number. So if she's reading 4 books per week, and she ends at 45, that would be 4 books times the number of weeks is equal to 45. That'd be an appropriate equation to come up with. It needs to be written as an algebraic equation with a variable. A lot of you wrote the multiplication or the division that you were doing to solve it, but that's not an equation as we're looking at it here. Then to get part B, if you divided both sides by 4, then you'd get the 11.25 weeks. So, probability of a spinner, that was a weird one. The probability that it will not land on it 3 times. Well, it could land on it twice. That's not 3 times. It could land on it once. That's not 3 times. So I think the easiest way to do this problem is to figure out the probability of it landing on the letter D all 3 times in a row. And that probability is a fourth times a fourth times a fourth, which is 1 over 64. So then all of the other instances or times that it doesn't land on D 3 times in a row, that's what your answer is that you're looking for. So that's going to be 63 out of 64. That's the complement of it. It either does or it doesn't. It either lands on it 3 times in a row or it doesn't land on it 3 times in a row. And then number 9 was hard. No doubt about it. Some of you are going in the right direction, and maybe you lost just a little bit, but it's like this. If the assessment is $3,300 a year, and it goes up 5% over 4 years. In the first year, you could either just multiply this by 1.05, which is 105%. So her assessment's still going to be 100% of what it was, plus 5% more. So you could do this to get the first year. Or you could say it's going to be 3,300 plus 0.05 multiplied by that much money. That would give you the same answer as if you just took and multiplied by 1.05. Don't worry, we'll spend a lot more time with this kind of stuff next year. You see, if we just took 1 multiplied by this, and then 0.05 multiplied by this, here's the common number multiplied by this added to 1.05. So I don't know what you get. I'm not sure what you get. But that would be the first year. And then whatever you get here for the second year would be multiplied by 1.05 again. Because it's 1.05 or 105% of the previous year. So what we do is we think of it like this. Times 1.05, this is year number 1. Year number 2 would be this amount again. So it'd be 3,300 times 1.05. I'm gonna put them in parentheses, that'd be easier with all the dots. Times 1.05 again. In the third year, would be 1.05 times 1.05 times 1.05. In the fourth year, I'm getting tired of writing 1.05, so I'm just gonna say 1.05 to the fourth power, because here it's the third power, the second power, and the first power. Yes, hard question. We'll spend a lot of time with that next year. Yes?
I have a question on southern one. So you say 1/4, like, wait, what was the equation that you used
So this is the probability
of it landing on D? Like you're supposed
on
to find.
D 3 times.
Yeah.
Right.
Aren't you supposed to find the probability of it not landing on D?
Yes, that's why I circled 63/64ths.
But why would it be, where'd you get the 63 from?
Well, if it lands on D 3 times in a row, that's 1 out of 64.
Okay.
So not doing this would be the complement of it. If you think of the spinner one time, I don't know how it's arranged, but let's say it's arranged like this. Let's just do it. What's the probability of landing on D one time?
1/4.
The probability of not landing on D,
3/4.
3/4.
Uh,
That's one time, but when you do it 2 times, it's different. You can't, some of you did take 3/4 times 3/4, you can't do that. Because you got 3 spins. And you could get A, B, C, or D on the first one. You could get A, B, C, or D on the first one. In fact, you could get D on both of these. And if you don't get D the third time, then you did not get it 3 times in a row. So there's no easy way to calculate other than taking, if it does happen, and then its complement is if it does not happen. Yeah, the type of probability to do it the other way and think of it one spin at a time, we haven't done that kind of math yet, and we'll do it some next year. That's, it's really, really hard to keep track of all of the different possibilities. So the math that we use for that is actually really, really complicated stuff. You know, you think about it this way, like if you flip a coin 3 times in a row, what's the probability of getting heads each time? 1/2 times 1/2 times 1/2, 3 times in a row. That's 1/8. So that means there's 7 other possible ways of flipping a coin heads, tails, where it doesn't show up 3 heads in a row. And that it might involve 2 heads and a tail. 1 head in the tail, or no heads, all tails. Okay, let's go back to simple stuff like division again.
So,
Yeah?
number 4 would 11 weeks be wrong?
Yeah, because it takes a little longer than 11 weeks.
11 to 12 weeks?
Well, 11 to 12 weeks, but you were supposed to get an exact answer from that.
11.
And that's why, 11 and a 4. See, this is the problem. If you had, or this is the equation. If you wrote that equation, then you could solve it exactly like this. And, you know, part of what this set of lessons has been is doing things explicitly, very exact. And writing models that describe a situation. So that's what we're doing with this. And that's why the one lesson was this right here, solving equations like this, writing equations in this form. So here's a problem, a problem for you, without looking in your book at how they solve it. If I give you this kind of a problem here. So a car travels 243.4 miles. And 12.1 gallons of gas. How many miles per gallon do they get? And this is the scenario. Here's the question. How many miles per gallon? So without doing the actual arithmetic, just write down on your paper what you would do with those numbers. Don't do the arithmetic, don't stick it in a calculator, just write what equation you would be solving. And that gives you the whole together. You'll have less pages of paper to fumble through. Don't worry about what the answer is. The answer is irrelevant right now. It's just how would you write it? Okay, then, if you wrote it with one of these, change it to a fraction bar. If you wrote it with a fraction bar, also write it with that division symbol. If you didn't write it with either one of those, have one of us come take a look at what you did. Okay, so then write it with a fraction bar. So Arla, if you write it this way, which number did you write first? 12.1? And then you'd have 243.4 over here. Okay. Does anybody write it the other way?
Yeah.
You wrote it the other way. Okay, so I'm going to write 243.4 divided by 12.1. Is that okay? Okay, now I'm going to write it over here two different ways. Fraction bar, 243.4 and 12.1, and 12.1, 243.4.
What if you did a ratio?
A ratio. A ratio like 243.4 to 12.1?
Yeah.
Yeah, if you do that, then this would be changed to a fraction like the first fraction on the left. It'd be the first number is the numerator divided by the bottom number. So this is a ratio, but a ratio is usually left as a ratio. It doesn't have any math done to it. Hayden?
About like a long division thing.
Oh, if you did the long division, what did you put underneath the doghouse?
243.4.
And 12.1, okay? Which of these two goes with this? Left. Which of these two goes with how it's written under the doghouse?
Left.
The
Right.
Top divided by bottom, top divided by bottom. Inside divided by outside. Okay, I'd like to look at it this way. And actually, I want to look at it this way. This side of the board I think is better. What do I have? I didn't even have the whole board in. look at it this way. What does 243.4 stand for?
How many miles to travel?
Miles. And 12.1? Gallons. Okay, so if you did the division, what's 243.4 divided by 12.1? Go, you have calculators.
20.1.
20.1
Yeah, basically.
miles per gallon. So if you look at the question, how many miles per gallon, does this answer our question?
Yeah.
Yeah. So the point behind this is if you put your units into place, it will tell you whether your answer makes sense or not in terms of the question being asked. So let's go to the second one. What's 12.1 divided by 24, or 243.4? Point what? Now, all these calculators, you need to help me. I don't have this in my head.
0.49.
0.49 to keep going?
Yeah.
Yeah, that's fine. Gallons per mile. So it's 0.049 gallons per mile, so roughly 500, so 1/20th of a gallon per mile. See, this is really close to 1/20th. So if you use 1/20th of a gallon in a mile, and you go 20 miles, that's about like 20 miles per 1 gallon. So this is what we're looking for here. If we write like this, then we have 243.4 miles divided by 12.1 gallons. And we end up having to decide how to write the miles and the gallons in our answer. So, with the work that we're doing in this lesson, this is not what we're looking for. This is what we're looking for. This here is called a unit rate because there's 1 in the denominator position. And we can think of this as 243.4, the numerator divided by 12.1, and the denominator also divided by 12.1. So you can look at it as just simplifying a fraction, or simply taking that division, it becomes, whoops, went too far, becomes our numerator divided by 1. So in this lesson, the key is that you have to include units everywhere. Everywhere that you write a division, it's going to be the division of 2 different units. So this is the rate model for division. This is what it's called. Math has very little meaning if we do not have units to apply. It's just numbers otherwise. What are you doing with your what? Yeah. So was your rate of writing different left-handed versus right-handed?
No.
Some people said yes, some people said no. And you expressed your rate in what, letters per second?
Yep.
Instead of seconds per letter. So you could do it seconds per letter too if you flip it upside down. So these two here, these are called reciprocal rates because all we've done is taken the reciprocal of the fraction. But the key to this lesson is we have to decide what is the best way for our answer to appear so that it's understandable. People usually talk about miles per gallon. They don't talk so much about gallons per mile when it comes to traveling. Although, with the ferries, it's like gallons per mile. Hundreds of thousands of gallons per mile. What's that?
You convert it to liters per kilometer.
Yeah, you could convert it to liters per K, but we're not gonna do that today, I don't think.
It's like
I don't think that's a
radius.
part of this game. Yeah. I'm just gonna give you your homework. It's gonna be on page 564.
What?
564. Numbers 1 through 9 and number 12. 1 through 9 and number 12. So there's one question that you're actually going to have to look back and read. But the rest of them, like a package of 16 rolls of paper towels costs $11.99. You need to calculate a rate that makes sense. Do you want to have dollars per towel per roll, or do you want to have rolls per dollar? And then arrange your fraction accordingly and do the division. 1 through 9 and 14. Oh, I'm sorry, no, 12, you're right. 1 through 9 and 12. And 12 is all about cows, which is cool. So every one of these, from number 2 on down, you're going to be writing with the units in fraction form, so that when the units come out in the answer makes sense.